Hello everyone, I'd like to welcome all of you for another video tutorial session for the drug designing laboratory course. And in this session I am going to demonstrate how to use a modeler for advanced homology modeling. In specific, I am going to demonstrate you how to use modeler for modeling ligands in the binding site of the protein molecule. So these are the softwares which are required. I hope you already installed the software for the previous session. So we need modeler. The latest version is 10.1. You can get it from this web address. So if you want to generate the energy plot, then we have to use some Python packages for generating the graph. So I highly recommend you to install Python 3.8.9, which is the latest version, along with NumPy, SciPy, Matplotlib packages. So these are the packages we will use for plotting. So what are the needed files for this specific tutorial session? I'm going to take this sequence ID. So this I am going to take as the target sequence, so which is a regulatory protein SDIA. So this is a target protein which I have already downloaded from Uniprot, and I have given in the needed file folder in Google Classroom as sdia.ali. That's a file for this target file. So let me tell the background of, okay, so this is what actually we did in the previous session. So in the previous session, to some extent, we learned how to use modeler for the basic modeling. So we took TVLDH and we modeled this protein molecule by choosing some suitable template, and we aligned the target and template. Then we generated the model. We did model evaluation using some Python script within modeler. So we identified certain region as having some energy issues. So then we went for the advanced modeling technique in which we used multiple templates, and then again we plotted the energy graph, and we identified that there is a drastic decrease in the energy of the model in that specific region between 90 to 100 amino acid. So that is what I covered in the previous session. So in this session we are going to model I am going to demonstrate how to use modeler for modeling ligands in the binding site. So let me give some idea about what is the need for this type of modeling. Okay, say for example you have some target sequence. Okay, so this is the target sequence, and you want to model the target sequence. Okay, so you have identified some template for modeling this target sequence. Say you got two templates, good templates. So one is it's not co-crystallized with any ligand molecule. The another one is co-crystallized with some drug molecule. Okay, so since this protein is already having some bound ligand molecule, drug molecule, then it is better to choose this as the template. Because if we choose this as the template, then we have some advantage that we know where the ligand will go and bind. Okay, so we won't give preference for this protein alone. We will try to find the template that is already having some bound ligand or the drug molecule. So we will use that as the template for modeling the target. So in homology modeling, in advanced homology modeling, there are possibilities that this template can be modeled even along with the co-crystallized ligand molecule. In the previous session we learned how to model the protein. Okay, so how to model the target sequence with the help of template. So in this session we are going to see that how to model the structure of the target using template along with the ligand molecule which is co-crystallized in the template. Okay, that is what we are going to do in this session. I hope you understand, right? So I kept all the needed files in this folder. Okay, so this is a folder in which I have all the needed files. So let me tell what are the different files which I have in this. So these are the Python script. Okay, so these are the Python scripts which will be used for modeling, and this family. Okay, so this file is having details of the substitution matrix for doing the alignment. This is also a Python script. And this PDB95, this file we already used. So this file contains the amino acid sequence of all the protein molecules which are already deposited in the protein data bank. And this is the target sequence. I told that I already downloaded the target sequence. I prepared the target sequence as the ALI file format, and I saved that file as sdia.ali. So that is the target sequence. Okay, so these are the important files which I kept in this folder called Modeler Advanced Ligand. So for this folder, I gave the link for this folder in Google Classroom, so I can use the same set of files. Okay, so as I said, this is the target sequence which I downloaded from Uniprot and saved it as sdia.ali. Let me open this using Notepad++. Just to show you what's the content of this file. So this file, I hope that this is not new for you, because the same file format we have used for the previous session for the basic modeling and multiple template advanced modeling. So this file format is called as PR file format. So here it starts with greater than symbol, then we have the information about whether it is a protein sequence or nucleotide sequence. P1 stands for protein sequence. There's a semicolon, and then SDIA is a small annotation about the sequence. So since this is SDIA protein, I have given this name SDIA. It is optional, you can give any name. So then we should not disturb this line. Okay, so we should not delete any of this colon. So we have to keep this as it is, because that is the syntax. So and here again we have the same information SDIA. So whatever is used here, you have to use the same name here also. Then I copy paste the target sequence here, and it should end with the asterisk symbol. So this is the protein sequence, SDIA protein of uropathogenic E. coli, for which there is no experimentally determined 3D structure. So we are going to model this protein by choosing some suitable template, okay, with the help of the modeler software. So this is the target sequence. So the very first script what we are going to use is this build profile.py. So let me open this build profile.py and show the content of build profile.py. So this is the content of build profile.py. So already I discussed this in previous session. So let me again tell. So what are the details that we had to input? So first detail we had to input in this line number 10 about what is the sequence database we have. So as of now I have the database with the name pdb95.pr. So this is the sequence database file. So again I am repeating that this file contains the sequence of all the structures which are deposited in the protein data bank in PER file format. So that information. So already we have this file with the same file name pdb95.pr. So no need to change anything here. If your file name is different, you have to change here. So again database set database file name, same file name. So no need to change any of this. Okay, so here we have to make some change. Okay, because by default it is given as the target sequence is given as a tbldh.ali, but our target sequence file name is sdia.ali. So we have to replace this tbldh.ali with sdia.ali. sdia.ali. So next, if you open this sdia.ali, here you can see this is the align code. The align code is given as SDIA. In this position and this position it is given as SDIA. So the align code here, the align code is okay, align code is not it is not mentioned anywhere, right? So no issues, right? So this is the file name sdia.ali. So let me clear the annotation. Okay, yeah. So the next is we have to look for what are the changes we have to do. This is in PR file format. Okay, so the final output is going to be build profile.ali. No need to change, right? So we can keep the same file name. So I think that's the changes that we have to do, and we done with the changes, and we can save this file by clicking Ctrl yes, and I'm ready to run this script build profile.py. So in the last session also, in the last session itself, I told you how to run modeler. So I'm going to open the modeler software. So I opened the modeler software from the start menu. The software is open here. So first thing is I had to direct, okay. So first thing what you have to note down is that what's the version of the software which is installed in your computer. So here I have installed a 10.1. Okay. So the version is 10.1. So the command for running the modeler in my case is going to be like mod 10.1 space the script file name. Okay, so this is going to be the script file name. So this is how I have to run the modeler on my computer. Okay, so this is a command for running the modeler on my computer. 10.1 is the command, right? So version. So first I have to locate the folder where I have all the needed files. So for that I am just copying this link where I have all the files. So I just type cd space, I gave the current location of the folder. So now I am in modeler advanced ligand folder. So I just type dir, so which will display all the files which are present within the folder. So we are now ready for, we have all the input files which are required for running this build profile.py. So I think we can now run the command. So for running the command, now again I write here. So since my modeler version is 10.1, so my modeler version is 10.1 here. So the command for my case is mod 10.1 space the script file name .py. Okay, this is a command. So let me type it here. So mod 10.1 space the script file name is, we are going to run this script. We're going to run this script build profile.py. So that is that name I had to give here. So I'm going to type that space space build profile.py, just enter, right? So it may take a couple of seconds for finishing this. So if you get this import site failed use -v traceback, no need to worry about that. Okay, this is not an error, so which means that it is running. Okay, so we had to wait for the completion of the process. So also you can see here the cursor is blinking. Here you can see the cursor is blinking. Okay, so which means that the program is running. So once if it stopped the blinking and if the line is terminated and the next line appear like C:/user/Karthi Shanmugam, which means that the process is over. So here we got some error. So let me check what is the error. So cannot open tvldh.ali. Okay, so let me check this script again. I don't know whether I have saved the script correctly or not. So build profile.py, I am opening this using the text editor again. So I have to look for where I have this tvldh.ali. So actually I have changed that to, so let me erase the annotation. tvldhsdia.ali. And I don't think that we have tvldh anywhere. So let me check. Okay, so I think I did not save the file. Control S is for saving the file. So again I go for this and again I am running. Okay, so I am in the folder desktop. Yeah, the folder location is correct. So let me run it again. Okay, so we'll see whether we are getting any error. I think I forgot to save the text file after edition. So it actually takes time because it has to compare the target sequence with all the sequences which are present in PDB95. So PDB95, it's a very big file because it contains all the protein sequences for which the structure is deposited in the protein data bank. So it may take some time and we have to wait for the output. Okay, so this time we got, right? So no error is displayed. and the cursor got terminated and the next line is displayed here, right? So which means that the script which ran successfully. So we'll check the output file. The output file from this run is this file called as build profile text file. You can see some text file here, text document. So this is the final output file, one of the final output file from this step. So I just opened this using Notepad++. I just wanted to show you whether it is successfully completed or not. Yeah, it is successfully completed. And the area of interest here is that this region is very important, as I discussed in my previous session. So these are the templates which are identified in this step. So these are the sequences in the PDB 95 folder, in the PDB 95 file, which are highly similar to the target sequence SDIA. So these are the PDB entries which are having very close sequence identity with SDIA. So as I said, this column is very important and this column is very important. So this column denotes the E value and this column denotes the percentage of sequence identity. These are two important columns, right? So what we did in the previous session is that we have taken only the IDs which are having the E value 0. Because E value plays a very important role, and also we have to give importance for the percentage identity. The percentage identity should be high, right? So you just run the compare.py on your own and you just think of which template is the best template. So as I have good knowledge about this protein, I am going to choose this 2AVX of A chain as the template for modeling. The reason for I choose this is because it's having 95.91% sequence identity. Even we have sequence with 97.88 4 LFUA, but I'm not going to choose this because it's not having any co-crystallized ligand molecule, but this 2AVX of A chain it has a co-crystallized ligand molecule. So it will be very much easy for me to model the target along with the co-crystallized ligand molecule, so that I can easily define where the binding site is present for the docking and other procedures, right? So in that aspect, for me, right, so it is optional for me. I feel that it is good to choose this 2AVX for this example. So I'm going to choose this 2AVX as the template. Okay, I'm not going to run compare, right? So I leave it to you. So if you want, you can run the compare.py and you make your own choice of which one is the best template. But ensure that the template is having co-crystallized drug molecule or some inhibitor like ligand molecule. So with that, I already downloaded 2AVX. I have the PDB structure of 2AVX, right? So I'm going to align now the target with the template 2AVX. So let me open this template using Notepad++. So this is the template I have downloaded from Protein Data Bank. This is actually having many models, because the structure is all using NMR. So I think more than 9-10 models there. So I deleted all the models. I kept only one model, the first model, because that is the best model. And if you scroll down, you can see here this HTF is the ligand molecule, co-crystallized ligand molecule, which is already present in this complex. So we are going to model SDIA.ALI, which has a 95% sequence similarity with 2AVX, and we are not only going to model the protein, so we are going to model along with this ligand molecule HTTF. So that is kind of advanced modeling which I am going to demonstrate now. So for that, first step is very simple, very same what we did in the previous session. So we are going to make the alignment between 2AVX and this SDIA.ALI. So for that, we are going to use the script called as align2D. So let me open this script using Notepad++. So this is the script. So here already I have made the changes just to avoid reducing the time. So here this is the place where we have to tell what is the PDB code we have taken. So we are choosing 2AVX. of which chain. So first chain and the last, both are A chain. So this is aligned code. What is aligned code? 2AVX of A chain. We are going to use only the A chain for this modeling. And which file contains the atomic coordinate? So 2avx.pdb file. This is the file which contains the atomic coordinate. And what is the target sequence file name? The target sequence file name is sdia.eli. And what is the aligned code given in the target sequence? The aligned code is sdia. And what should be the output file name? So I have given sdia 2avx.ali and sdia 2avx.pap. So it is going to output two files. So once if we successfully run this script align2d.py, so it is going to output two files which will contain the information about the alignment between the target sequence sdia.ali and the template sequence 2avx. So let me erase this annotation. So we are ready for running this. Okay, let me run this. So as you know how to run this, so the command is going to be mod 10.1, and this time the Python script file is it's going to be align2d.py. So align2d.py. So if you press enter, the script will start running. So which means that the alignment process started. It's not taking time because it's just aligning only two sequences, our target sequence and template structure. So it did not take too much time. It took fraction of seconds, right? So we got the output file. So let me open this align2avx.pap. So these are the two files which we got as the output from this script. So these are two files. So PAP is, we can easily, as a human, we can easily read this PAP. So, but we input the .ali file. In the next step for the model building for the computers, they can easily read that .ali file. So let me open this .pap using text editor just to show you the output. So this is the alignment which is made between the target and template. So the target is SDIA. So this is the target sequence and this is the template. So the alignment is made between the target and template. So here we have a huge gap. No need to bother about the right, because the binding site is present in this region. So we have complete coverage of the binding site in that specific region. So no need to much worry about this loop. We'll be getting this as a big loop, right? Doesn't matter. So this is alignment made between the target and the template. Okay, so let me erase the annotation. Let me close, minimize this. So okay, so our intention is that we have to model. Okay, let me open again. So our intention is not only modeling the amino acid sequence. The alignment is now made between the amino acid sequences between the target and template. But our intention is not only making the model of the protein. So we have to model along with the co-crystallized inhibitor or ligand molecule. So how to do that? So for that, so we have a script called as model ligand.py. I have given in the needed file. So let me open that file. So model ligand.py. So in this we have to input the details for modeling. So let me show what are the important places where we have to. So this is the alignment file which we got in the previous step. This file sdia 2avx.ali. So what is known as the 2avx? Okay, so this is the known 2avx because we already know what is the structure of that, and the sequence unknown is sdia. Sdia, this is the unknown. So these are the only informations that we have to give. How many number of models we need? Starting model is 1, ending model I gave 4, which means that it's going to output 4. But nowhere we have mentioned that, okay, so how it is going to incorporate the ligand molecule, because we are, if you look at this file carefully, so here we have invoked that environment io.het atom is equal to true. So what it does, it's going to incorporate the ligand molecule that is present in the template to the target modeling. In the model, it'll incorporate that heteroatom present in the template. Okay, so that's what's going to happen. So for that, in the alignment file also we have to define that ligand should be model. So for that, I opened this sdia2avx.ali using Notepad++. and let me erase the annotation to avoid confusion. So here the total number of amino acid in the PDB file is 171 for this alignment. So let me open this using Notepad++. So here the amino acid starts with most probably I think it starts with the first amino acid. Yeah, it starts with the first amino acid, and if we look at the ending amino acid number, it ends with okay, the total number of amino acid ends with 171, but 172 is the heteroatom. So we have to model this heteroatom along with the protein. So now if I go back to the alignment file, yeah, this one. So here it is 171, but 172 in 172 position. So let me write it here. In 172 position, we have the information about the ligand molecule, which is the HTF. So we have to model this HTF. Okay, its position is 172, right? So as of now, if we run this, it won't input any ligand molecule in the model. So what we have to do is that we have to change this to 172. So now it is 172, and so we have 171 position in this alignment. So I have to add the 172nd position by just adding this dot symbol. So I have to do the same thing for the template as well as for the target. So 2AVX is the template, as well as I have to do the same thing in SDIA. This I do in the .ali file, not in the .pap file, because this file is going to be the input for the model ligand.py. So I just save this file. I have saved this. So only two changes which I made here is I changed this 171 to 172. I added one dot in the model and one dot in the target and template sequences, right? So now I am ready for running this model ligand.py. Okay, so all the file names are correct here. So I am saving this file. I just go to this modeler command prompt. So in which I am going to run model ligand.py. So what is our expectation this time? So we'll be getting 4 models because we asked to generate 4 models. So all the 4 models will be having the protein model along with ligand in its binding site. Because 2AVX is already having some ligand molecule, co-crystallized ligand molecule. We are asking the modeler to model the protein of the target sequence along with the existing ligand molecule in the template. So let me run this. I hope it'll okay, so it is showing some error. So the align code is 2AVX. Okay, so I think I have some problem with this alignment file. So let's see. Yeah, the align code is 2AVX, not 2AVXA. So I remove that A. Okay, so I removed this A and I saved the file. So I'm going to try to run this again. So let's see whether it is successfully running. I hope it is successfully running because the cursor is blinking. I did not receive any error as of now. So we have to wait till the completion of the 4 models. It may take some time. So we have to wait till the cursor gets terminated and the next line appeared in the command prompt of the modeler. Okay, so now the process is over. So if you look at the cursor is not blinking, it is terminated and the next line is displayed. Okay, so which is the indication that the process is over. And so if you look at the folder, right, so these are the new files which are generated. So these are the models which are generated for our target sequence. So we gave, if you remember, we have 4 models maximum and 4 models got generated. The first model is this 90001, 0002, 0003, 0004. These are the 4 models, right? So what I'm going to show you is that we will check whether the model, it is modeled along with the ligand molecule or not. So let me open the first model using Notepad++. Okay, so this is the atomic coordinates of the first model. So if we scroll down, so we have the information for all the amino acids up to 244 is amino acid, and 245 here, if you look at the model, is having HTF. Okay, so which means that the atomic coordinate of this HTF was taken from the template 2AVX and kept in the model of SDIA. So let me show this using some molecular visualizer software. So I'm So let me open that file, go to desktop. Okay, so modeler advanced ligand. So we have 4 models. I'm opening the first model. Okay, so here, this is the first model. And here you can see the sticks. Okay, so here, okay, let me show it clearly. So go to actions, atom bond. I'm going for backbone only, minimal. Yeah, so now the protein is shown as the cartoon, and the ligand molecule. So this is the ligand molecule which is already modeled in the binding site. So maybe I can change the color for better representation. So go to action, color. So I just go for all option. So in which I'm going for very different color. So I just go for maybe some blue will be contrast, and by heteroatom and give close. So now you can see now very clearly that the protein SDIA, which is modeled along with the co-crystallized inhibitor or the ligand molecule, right? So in this way we can model our target protein molecule along with some co-crystallized drug molecule or the ligand molecule. This loop we have to either delete this loop or we have to model this separately, right? So I hope you understand that how to use modeler for advanced modeling for modeling the protein along with the inhibitor or the drug molecule or any ligand molecule. If you have any queries, just write to us. I will clarify that. Okay, thank you.